So today we'll be working on Chapter 7, Practical Problem number 24. This is going to be Part A. So we're going to let n represent the number of small pills and m for the number of small pills created by splitting a large pill. We're going to define a variable zi, where zi is equal to 1 if the ith pill remains after the last large pill is eaten, 0 otherwise. So here, if a large pill is eaten, we don't eat the whole pill. We eat half the pill and create another small pill. As in the instructions, we will define a variable x such that x is equal to the sum of the variable zi, where I is from 1 to n plus m. Our goal is to find the expectation of the variable x, but we defined x as the sum from I to n plus m of zi, so we can replace x with z in the sum. Using the properties of expectation, we're able to move the expected value inside the sum. So we get the expected value of z sub I. But here, that's just equal to the probability of zi equaling 1. This brings up two different cases. Case 1 is where our index I is between 1 and n. So here, the probability is equal to 1 over m plus 1. And case 2 is after the first interval, n plus 1, and then n plus m. Here, the same probability of the variable is 1 over jm from the sum j is equal to 1 to m. So we go back to original expected value. We can split this up into two different cases that we talked about, where I ranges from 1 to n, and where I is between n plus 1, which is after n, and up until n plus m. So using the formula from before, we can multiply n to this to get n over m plus 1. And this is equal to m times the sum from j equals 1 to m over 1 over jm. So we can bring the m inside, and that will cancel with this m, leaving us just 1 over j. So our original goal is to find the expected value of x. But here, we can't simplify the sum, because I believe this is the partial sum of the harmonic series, and there's no nice closed form for that. So we just get the expected value is equal to n over m plus 1 plus the sum from j equals 1 to m over 1 over j. For part B, we're going to let y denote the day on which the last large pill is chosen. We also know that it takes n days to consume only the small pills, if there's n of them. If there's m large pills, then it's going to take 2m days to consume only the large pills and the smaller pills, or the smaller halves that are created from eating the first half of the larger pill. The textbook hints that we want to consider the relationship between x and y. If we add x plus y, we get n plus 2m. So we want to find the expected value of y. We first want to get y by itself. So we just subtract x over to the right-hand side. We take the expected value of y, but y is just equal to this that we just previously found, so we can plug that inside. We're going to use the properties of the expectation, which is linear, so we can split this up into 3 parts. So the expected value of n plus the expected value of 2m minus expected value of x. N and 2m are just constants. So we can just replace that with just a pure constant. The expected value of a constant is just a constant. But x is a variable. So we have to have minus expected value of x here. The expected value of x is the same expected value that we found before. So you can just copy this over here to get a full formula. but this should be fine.